Hello viewers, in today's session we are going to solve a linear programming problem using simplex method. Maximize 3x plus 4y subject to x plus 3y less than or equal to 30, 2x plus y less than or equal to 20 and x and y are greater than or equal to 0. This is what is the problem given to us. We are going to use simplex method to solve this linear programming problem. If the problem is in standard form only, simplex method can be used. The requirements are, the problem must be a maximization problem and the constraints must be in the form of linear equation and all the variables must be non-negative in nature. In the given problem, the linear function or the objective function is going to be maximized. So the first constraint is satisfied and both the variables are non-negative in nature. So the third constraint is also satisfied, but the other constraints are not in the form of linear equation. So we have to convert the constraints into or in the form of linear equation by introducing slack variable. The very first constraint is x plus 3y less than or equal to 30. We are introducing a slack variable u. So plus u is equal to 30. And the second constraint can be written as 2x plus y plus v equal to 20. So we have introduced two slack variables u and v. Okay. And so those two slack variables are going to be introduced in the objective function also. So the problem is going to be maximize 3x plus 4y plus 0 into u plus 0 into v. Now the problem is in the standard form. So we can apply simplex method to solve the given linear programming problem. In the very first step, we have to identify the basic solution which is satisfying the constraints. The basic solution is x and y equal to 0. So, that solution is going to be represented as a table in the first iteration. So, in the table, we have to introduce all the variables in the columns. 4 variables are there. So, it can be written as x, y, u and v. So the very first solution, the basic solution we are going to represent here is x and y both are equal to 0. So if you substitute x and y equal to 0 in the first constraint, we will be getting u is equal to 30. So the name of the very first row is u and u, the value of u is going to be 30. So that is written in the very last column of the table. And if you see the second constraint and if you substitute x and y equal to 0 in the second constraint, we will be getting v is equal to 20. That is going to be represented in the second row. So name of the second row is v and its value is equal to 20. So in the first row, the first constraint is going to be represented. Here we are going to represent all the coefficients. So coefficient of x is 1. So that is written here. Coefficient of y is 3. 3 is written. U is 1. So 1. And there is no v term here. So coefficient of v becomes 0. Now in the next row, second constraint is going to be represented. So coefficient of x is equal to 2. So we are writing 2 here. Coefficient of y is 1. So we are writing 1. Coefficient of u, there is no u term in the second constraint. So it is written as 0 and coefficient of v is 1. Now we are going to write the objective row. Objective row can be written from the given objective function. Here before writing the objective row, all the coefficients must be negated. So coefficient of x is 3, that can be written as minus 3. Coefficient of y is 4 in the objective function, so that can be written as minus 4. and coefficient of u is 0, coefficient of v is 0. If you substitute x and y equal to 0 in the objective function, the value will be equal to 0. So that is written here. So this is the basic solution. This is the result of the first iteration. After finding any one solution, we have to do the optimality test. We have to check whether the given solution or the present solution is an optimal solution or not. For that, we have to check the objective row. The very last row is called as objective row. We have to check the values present in the objective row. If all the values are positive, then the present solution is going to be the optimal solution. If any one value is negative also, this is not the optimal solution. So if the solution is not an optimal solution, we have to identify the entering variable by identifying the pivot column. The column with the most negative value in the objective row is going to be the pivot column. So the very first the most negative value which is available in the objective row is -4. So this column is going to be the pivot column, and the corresponding variable y is going to be the entering variable. Now in the next step, we have to identify the objective row for finding out the departing variable. For finding the objective row, we have to calculate theta ratio. Theta ratio can be calculated only for the rows with positive values in the objective column. So it can be calculated only for the first row and second row. And the formula for calculating theta ratio is the last column value divided by the corresponding pivot column value in the corresponding row. So here it is going to be 30 by 3, which is equal to 10, and for the next row it is going to be 20 divided by 1, which is equal to 20. Okay, so the theta ratio of the first row is 10, theta ratio of the second row is 20. So for the third row it is not needed to be calculated because it is a negative value. Okay, now have to identify the row with the minimum theta ratio. So this is what is going to be the pivot row, and the corresponding column is going to be called as departing variable. Now we are going to represent the next solution in the second table. This is what is the second iteration. Here there is no change in the column names x, y, u and v, and instead of u we have to write y. U must be replaced by y. Okay, so y and v can be written as it is. So the next table is going to be written. The element which is available in the pivot row pivot column is 3. Okay, so first of all we have to write the new row. So all the values in the pivot row must be divided by pivot element, so that we will get the new row. So here already existing value is 1 divided by 3 will be getting 1 by 3, and here 3 by 3 1, here it is 1 by 3, and then it is 0, and here it is going to be 10. And now we have to calculate the second row and third row using this new row. This row is called as new row. Okay, using this new row we have to calculate the second row and third row. Formula for calculating second row is row 2 is equal to already existing row 2 value minus c into new row value in the same column. So this is what is the formula. And for calculating the third row, the formula is already existing value in row 3 minus c into new row value in the same column. This is what is the formula, where c represents the pivot column value available in the corresponding row. Now when we calculate the second row, C is going to be 1 because 1 is the pivot column value available in the second row. So here C is equal to 1. When we calculate the third row, C is going to be minus 4. So here C is equal to minus 4. So because minus 4 is the pivot column value available in the third row. Now we are going to apply the formula. Already existing value here is 2. So it is going to be 2 minus C is equal to 1. So 1 into the corresponding new row value in the same column, which is equal to 1 by 3. In this way only we have to apply the formula. So in this way we can calculate the next value as 1 minus 1 into 1. Next one is 0 minus 1 into 1 by 3. And here the next is going to be 1 minus 1 into 0. Already existing value is 1 minus C is 1 into the new row value in the same column is 0. Then here it is going to be already existing value 20 minus 1 into new row value 10. Now similarly we are going to apply this formula for calculating the third row. So it is going to be minus 3 plus 4 into 1 by 3. The next value is minus 4 plus 4 into 1. Next value is 0 plus 4 into 1 by 3. The next value is already existing value 0, 0, minus into minus 4 plus. Okay, so plus 4 into new row value is 0. And the next one is already existing value here is 0, minus into minus 4 plus 4 into new row value is 10. Now if you simplify these values, we'll be getting second table as x, y, u, v. It is y, v. Here it is going to be 1 by 3, 1 by 3, 0. And the very last value is, last column value is 10. And here it is going to be, if you simplify 2 minus 1 into 1 by 3, we'll be getting 5 by 3. Here 0 minus 1 by 3. Then the next one is 1. Next value is going to be 10. Similarly, the third row is going to be minus 5 by 3. If you simplify, minus 3 plus 4 into 1 by 3, you'll be getting minus 5 by 3. The next one is 0. Next value is going to be 4 by 3. Then 0. The very last value is 40. So this is what is the table 2 we got. And here also we are applying the optimality test. Here we have a negative value. So this is not the optimal solution. So we have to repeat the same procedure one more time. Okay, again same procedure. Identify the pivot column. This is what is the pivot column, because the most negative value available here is minus 5 by 3. Then the next one is pivot row. We have to identify. For that we have to calculate the theta ratio. Okay, so theta ratio, how to calculate? The very last column value divided by the pivot column value. So 10 divided by 1 by 3, that is going to be 10 divided by 1 into 3, which is equal to 30. And here for the next one is 10 divided by 5 by 3. It can be written like this. So it is going to be, if you simplify, you will be getting 6. 6 is the theta ratio here. Theta ratio need not be calculated for the last row because negative value is available in the pivot column. Okay. Now identify the row with the minimum theta ratio. 6 is the minimum theta ratio. So this row is identified as the pivot row. Okay. So the entering variable is x, departing variable is v. So in the next table, this v will be replaced by x. So the next table is going to be, this is table 3. x, y, u, v, and here it is y, and here entering variable x we are writing. Okay, and the new row we have to calculate. How to calculate new row? We have to divide pivot row by the pivot element. 5 by 3 is the pivot element, because this is what is the element which is available in the pivot row, pivot column. Okay, so this is what is the pivot element. We have to divide all the values by pivot element. Okay, so the new row will be calculated like that. Then afterwards, similar to this, we have to apply the formula for calculating row 1 and row 3. Row 3, same formula we can use. For calculating row 1, the formula is going to be row 1 is equal to row 1 minus, the formula is row 1 element will be equal to already existing row 1 value minus C into new row value. Okay, so here when we calculate this one, the C is going to be equal to 1 by 3, because this is what is the pivot column value available in the first row. So we have to substitute C is equal to 1 by 3. If you do the calculation like this, we'll be getting the third table as 0, 1, 2 by 5, minus 1 by 5, 8, 1, 0, minus 1 by 5, 3 by 5 and 6. The last row value is going to be 0, 0, 1, 1 and 50. Now we have to do the optimality test. Here all the values are negative. In the objective row, the third row is going to be the objective row. All the values are positive. There is no negative value at all. So the present solution is going to be the optimal solution. Here the solution represents x is equal to 6 and y is equal to 8, and the maximum value of the objective function is 50. So the solution is x is equal to 6, y is equal to 8, and maximum value of the objective function is equal to 50. Thank you.